is a long cylinder, a long cylinder. So there is actually a coaxial cylinder. Let's have this one. So this is the long cylinder. Then I'm going to bring another contrast color. Okay, this is another cylinder which I'm going to drag. Both are long. Both are long. So let me bring that axis here. And this axis. Let's get into the. So what is radius R1? R1 is this one. What about R2? R2 is this. At least try to understand the question now. It is moved with a speed V naught. Where is the liquid? The liquid is here. Hope everything, intentionally diagrams are not given. I'm going to drag this cylinder. So now he is asking that conditions. Once we are able to do such problems, no, next Poiseuille's equation will be easy for us with the help of these things. Both are long. Okay, I'm just showing some finite length. The space between the cylinders is filled with a viscous liquid. So this is the viscous liquid. So what is this? This is a pipe. This is a solid cylinder. Able to understand question now? No. So what is asking? Find the velocity of liquid as a function of distance r from the axis of the cylinders. So he is asking now, there's a layer. So there'll be a layer. So what is the velocity of this particular? We are very sure liquid which is in contact with the pipe will be at rest, and a layer of liquid which is in contact with the solid cylinder will have velocity V naught. So as I move from axis to the pipe, from R1 to R2, what do you expect? The velocity of different layers will be different. Is asking the velocity at a distance R. So what is our question now? So the question is, at a distance R, what is the velocity of this layer? Fine. See, you are supposed to imagine, this is something very important. Let's get into the thing, that one. So I assumed a layer at a distance R. Okay, there'll be one layer above it and there'll be one layer below it. Will I agree this? So that particular layer all these are okay. There's a layer. I'm drawing little bit thick so that it'll be easy for me to explain it. In fact, it's a thin layer. Yeah. So this that layer at a distance r. So what is the thickness of all these layers? It is dr only. No, velocity of this layer be v. What is the velocity of this layer? V plus dv. Velocity of this layer will be v minus dv. I'm very sure velocity of this layer which is in contact with the solid cylinder will be v naught. And as you move, what will happen to velocity of layer? Will decrease. So therefore, what is this consideration? This is the layer which I'm interested. That is what we am showing. Able to understand? So I'm showing that is R. To make you understand, I'm showing little bit thick. Otherwise, not possible for me to explain. Okay, let's do one thing. There's a layer below and the layer above. No? So there's a layer 1. There's a layer 2. No. Tell me like in what direction the different layers, the layer 2, layer 1 will exert force on the layer which we are considering. So layer 2 in what direction will exert force? Compared to this layer, compared to layer 2, the layer will have more velocity. So the layer 2 should exert a force. This is a reference layer. Huh? Layer R, I'll write it better. Huh? Layer R. Velocity of this layer is more than this compared to layer 2. So therefore, the force by this layer should be in this direction, F2. Agree with this? On layer 2, it will be like this. By the layer R. Similarly, velocity of layer 2 is more than that of, less than that of layer 1. In what direction the force should be exerted? By the layer 1. By the layer 1, the force should be towards right. On this layer, it should be like this. Able to understand now? What is the net force acting on the layer R? It should be F1 minus F2. F1 minus F2. And what do you suggest, which will be greater, F1 or F2? F1 should be greater. So here F1 greater than F2. So therefore I want the resultant force acting on them. Now, what is F1? Eta A. What is the relative velocity between them? Should be dv. By dr. Similarly, what is F2? Eta A. V minus V plus, so it will be like a V plus dV minus V. I'll write it. Relative velocity, no, it is. Overall expression will write it. Again, I'll be confusing. The net force I want. F1 minus F2. What is F1 should be equal to? F1, what is the equation? Eta A relative velocity between them will be dV by dr minus of, this will be relative velocity will be eta A. Now please notice here, why do negative sign? The difference in velocity. So this will be dV. What is the difference in this velocity will be minus dV, no? So this layer will have less velocity than this. This layer was having more velocity than this. And the difference of that, you have to be taken. So this everything will become now 2 eta A dV by dr. What is A? What is area? So I'm going to take a cylinder. Of radius r and length l. What is the surface area of this cylinder? 2 pi rl. Fine. So this should be 2 eta So therefore, what is F is equal to? F should be equal to 4 pi eta L dV by dr. 1 r is also there. No? So let's simplify for this. So dr by r is equal to 4 pi eta L by F into dV. Anybody limit? We know at a distance small r equal to capital R1. What is the velocity? V naught. At a distance small r, let it be V. And that is what is asking V. But what is F? F is what the thing what we assume. No, let's see what we can do with that. Similarly, shall I go for one more limit? R1 at a distance R2. What is the speed of the liquid? Should be zero. No, will agree all of you? So what is the speed of the viscous liquid which is in contact with the solid cylinder? Will be V naught. Here, what is the state of liquid? Will be at rest. So therefore, the limits will come here. So I have to write a comment. Liquid at rest. In between there, we'll have a speed V. So let me divide these two equations. I'll slider dividing 1 and 2. So what do we get? dr So this will become equal to how much? Log of r by r1 log of r2 by r1 equal to v minus v naught minus v naught. Solving this, we'll get expression for v. I think this will be 1 minus v by v naught. So shall I write like this? V naught into 1 minus log of r by r1. This is the expression for the speed v. It's there in Edo. Just I picked up some very good information is there. Let me adjust it so that you'll not get confused. Everything is in order. Okay, no? So there's the one basic condition what we can put it. See, these are all some geometry based observation. You should very good in observation here. There's no concept. Everyone knows what F equal to eta A dV by dr. This diagram is very important. There's a layer which I am layer at a distance are how the forces are acting, This is the thinking. This will be there. This will, nobody wants to, no author will explain in the book because they want students to think. Don't blame author. That sir, the book is not good. You are teaching very good. See, even if I write book, tell me like why I should explain, because this is what you should think. No, once you know this, rest everything you can manage. Please be careful about the